Hi everyone and welcome back to the Multiverse of 100 plus data science project series. In this video, I am going to discuss about the liver disease predictions using Python and machine learning. This is an advanced types of machine learning projects. Let's see the today's agenda. What we are going to be covering on this project. First, we are going to discuss about the data preprocessing. Then we have the EDA, also called the exploratory data analysis. Then we have the data cleaning, like missing value handling or handling the categorical variable. Then we have in the removing outlier. There are so many methods are available in order to remove the outlier from the dataset. We are going to discussing all the steps. Then we have the various machine learning algorithm. We're going to apply some various machine learning algorithm in order to predict our liver disease. Then we have the hyperparameter tuning. So there are so many algorithms are available in Python called decision tree or XGBoost, which one having the hyperparameter. So we can tune in the hyperparameter in order to predict our liver disease. Then we have the model comparison. So above this model, we're going to select the best model and try to save it inside our directory. So now, without wasting your time, Har Har Mahadev बोल के start करते हैं tutorial. In order to building the liver disease prediction, we're going to using a dataset from the Kaggle that's called the Indian Liver Patient Records, which are collected from the northeast of Andhra Pradesh, India. So this is the dataset having some certain column, also called the features. Now using this feature, we're going to predict the liver diseases. Well, so I download the dataset from the Kaggle and make it liver.csv, and this is my CSV file, and also you can see here IPYNB file. So for that, I'm going to using here the Jupyter Notebook. You can also use the VS Code or Google Colab itself. Well, so first thing first, what I'm going to do is simply going to load the dataset from our directory that you see earlier. Then I'm going to import here the necessary library which one is required in order to building the liver disease predictions. So first, I'm going to import here the pandas as PD. Then we have the numpy as np. Let's import numpy as np. Then we have the cborn as sns, cborn as SNS. Then we have the matplotlib dot pyplot as plt. So pandas actually help you to do the data analysis, even though you can load the dataset using the pandas. Then you have the numpy, it's nothing but for the numerical computations, and you have the cborn, it's help you to do the data visualizations. Matplot is same like that. Cborn is working at the top of the matplotlib. So then I'm going to import here some listed color map, so that how you try to do the visualization of the correlation matrix, so that we can see, we can give here some different types of color. So for that, I'm going to import here from matplotlib dot colors. Okay, colors. I'm going to import here the listed color map. You can also use the tab from your keyboard. It will actually give you the auto suggestions from your Jupyter Notebook. So this will actually help us to give them some different types of color how you try to do the visualizations. Then we have the matplotlib inline, so that we don't need to type here matplotlib.show, I mean plt.show again and again. So it will show you this matplotlib plot inside your kernel. So let's say matplotlib.inline. Okay, that's it. Okay, you can also import here the warnings. If it's give me the warnings, so you can also import here the warnings. So in order to filter the warnings, let's say warnings dot filter warnings. So again, you can also use here the tab, and now you need to give here the actions. So action is I am simply going to ignore all the warnings. Okay, that's it. You can also import here the necessary machine learning library, but no, not now. We'll import it later on. Okay, now what I'm going to do is simply going to import the data set from our directory. I mean load the data set from our directory. So for that, I'm going to using here the pandas. So let's say pd dot read csv, read underscore csv, not csv, and I'm going to pass here my path. So let's say liver dot csv, and let's assign into the variable, let's call the df. Okay, matplotlib inline is not found. It's called the matplotlib inline is not found. Matplotlib, okay, not dot, actually it should be space. That's why it will give me this kind of error. Okay, fine. df equal to pd dot read csv. Then we have the liver dot csv. So shift enter. You can also using here this run button instead of that. So let's say df dot head. So now you can see here it having certain column: age, gender, total bilirubin, direct bilirubin, and it have the most of the like phosphate. Okay, and you having the column that's called the data set. So data set is nothing but my target column. Data set is nothing but my target column. So my target column is data set. Target column is data set. I mean, I have to predict the data set column. Okay, so this is nothing but my target column. Now the question is it a supervised learning or an unsupervised machine learning? supervised or the unsupervised? Supervised. Okay, it's obviously an supervised machine learning algorithm because it having the target column. Okay, so that's why it's supervised machine learning problem. Now it is a classification problem or the regression type of problem. It's obviously a classification type of problem. It's a classification types of problem. Now the question is it a binary classification or a multi-class classification? Yes, it is a binary class classification. Why? It having just two features. Okay, that's it, simple. Okay, now let's checking the shape of our data. So for that, I'm going to using here the df.shape. So now you can see here it having the 88 columns and 583 rows. This is my rows and this is my column. I try to use in the shape. Then we have the df.columns. That's df.columns. Okay, it will give you all the column which are available inside your data set. Now if I'm trying to checking the description or statistical analysis of your data, describe. Okay, describe, and you can see here df dot describe, and you can see here this is the statistical analysis of your data set. It having the count, it having the mean, it having the standard deviation, it having the mean, and it having the 25% percentile, 50% percentile, 75% percentile, and also the maximum number of value. Okay, simple. That's it. Now let's start the exploratory data analysis, also called the EDA. Okay, also called the EDA. So let's start exploring our data set. So now first checking that how many types of value are available. I mean object type, I mean categorical variable and numerical variable. So for that, if I'm using here df.dtype, let's say dtype, and I'm going to passing here df.dtypes equal to object object. It's nothing but help you to checking the categorical value. Okay, and you can see here we have just one column that's called a gender. If I go up, if I try to checking it another way, I can also using here df.info. Okay, so now it will give me the you can see data types. A float having 5, an integer 5, and one objects. This is how you can also checking for the numerical value and also for the categorical value. So is there any categorical value? I have to also handling those categorical value in my data set. Simple. So now let's try to checking the distribution of my numerical features. You can do the distribution of the gender, okay? Because gender is a categorical column. So that's why let's checking for the distribution of numerical features. Okay, features. Let's try to do that. You can also do it markdown. Okay, okay, let's try to comment out, otherwise you can also using here the markdown this one, and now markdown is created. Okay, now let's try to do the plotting the histogram grid. So for that, I'm going to using here the df.hist. Okay, df.hist, and simply I'm going to give here on figure size. Let's call figure size fixed size. Let's comma 5,5. Okay, okay, let's make it bigger, 15,15, so that it's good looks bigger. Then we having the xrot in the x-axis. I am trying to make it in a 45 degree in the 45-degree angles. I just going to rotate it. Let's say give here the beans. So how many bean size? Let's say bean size. Let's say 10 of bean size. Simple. Now I'm going to simply using the plt.show. Okay, that's it. df.hist. So it will give me the histogram. It will give me the histogram. You can see here the histogram age and the total bilirubin and the it's called the alamine, and it have the phosphate and the globin ratio, the albumin, and also data set. Now you can see here in the data set it having the two features column. I mean two features, two value. One is a 1 and second one is a 2. I mean it having two output column. So not two output value. So that's why it is a binary classification. Now here's the problem. You can see it's look awkward. This graph is looks like awkward. So what I can do is simply going to using here another things that's called the sns.set, and I'm going to using here the style. So plt dot style dot use, and I'm going to using here the ggplot. That's a ggplot, so that it's look better क्योंकि हम तो अब क्या बोलो सो एक्सपर्ट हो चुका है तो थोड़ा तो चाहिए ना स्टाइलिंग तो चाहिए, नहीं तो लड़की पसंद नहीं करेगा. Okay. Okay, let's try to now paint it out and let's see now distribution. Now it's look better. थोड़ा अच्छा लग रहा है अब. Okay. So you can see H, total bilirubin, then you have the direct bilirubin, and all of the things in a distribution, right? This is how you can also distribute your data set. So now what I'm going to do, I'm going to checking for the uh, data set, I mean the outlier. Okay, just checking for the outlier. So what I can do, I am simply going to using here df.describe, just checking for the distribution. Okay, we see that we have in the count, we have in the mean, and we having also the standard deviations. But it seems like in this data set, you can see it having the higher value. The maximum value is 4929. It's my maximum value. But if I see the mean value of that variable, mean value is quite large, 109. Okay, and also in this cases you can see this is the maximum, and also it having also the mean value. You can see 290. It's quite big. I mean, for this column, for this column, for this column, it having the higher frequency. See, the data set actually that's mean high you have the maximum value and the range to the maximum value. Okay, and the mean value is not similar types of. That's mean it maybe there should be the some outlier. Again, the max value, this max value, this max value, this max value is quite bigger than, is quite bigger than the mean value, right? See, there is a 290, so it is 2100. It's not so bigger. But in this case, as you can see here, it 80, okay, fine, but the value is 200. But here you can see here, the mean value is 109, and the maximum value is just like the 5000. That's mean there may be some outlier, maybe some outlier. Okay, but we can see that maybe that have outlier. We can actually try to actually creating the correlation matrix, then we can see that. Otherwise, how you need to try to plot in the box plot, then you can see that is there any outlier or not, is there an outlier or not. So now also there's the problem, you can see in the data set it having the 1 and the 2. So what I can do, we simply going to making this 1 to the 0 and 2 to the 1. We can also the other 2 to the 0 and 1 to the 1, same like, so that it's look like the convenient. Okay, so for that what I can do, if the score is negative, okay, if the score is negative, we can mark it 0. Negative means नहीं है, इसका liver disease prediction नहीं है. इसका if it is positive, that means है, so we make it 1, like that. So let's say I'm going to creating here a function. Let's call convert data set, like that. Okay, data set column, and it will take one x. So if the x equal to let's say 2, then we're simply going to make it 0. Okay, otherwise I'm simply going to return here 1. Okay, simple. Now what I can do, I am simply going to, so यहाँ पर तो semicolon नहीं देना चाहिए क्योंकि Python है. Okay, let's use it inside our data set column. So let's say data sets, and I'm trying to make it using here the df of data set, just trying to make it this 1 to the 1 and 2 to the 0, so that it look like the convenient, right? Dataset dot map, and I am going to using here the convert dataset. That's it. Okay, convert dataset. Now dataset is converted. So let's try to using here the dataset now. Okay, others you can using here the df.head. Should change so I say. Okay, and now you can see here the dataset right column is not converted into 1 and 0, but 0 is not showing up. So what I can do is simply going to checking the value count. So let's say data set dot value counts. Counts. Okay, we can do that. Now you can see it having the 1 and the 0. It having the 1 and the 0. Let's checking the distributions of the categorical variable. So for that we can tag the describe, and we can passing here the include And let's try to using here the object. Okay, this is the distribution of my object column. It having see it having a count 583. Well, unique value have two, I mean male and the female, top male, and frequency is 441. That's mean most of the people who are male having the liver disease, having the liver disease, and topmost value is male. Topmost value is male. So now what I can do is simply going to do the bar plot of this uh, gender variable so that we can see that if there are any uh, okay. So now let's do the bar plot. So bar plots for categorical features. Well, so you have to see that their count is 583 and unique value is 2 and top value is male and frequency is 441. That's really fine. Now let's try to using the pld.figure, and I'm going to give here the fixed size for figure size. So let's try to make it 5,5 because it's not so big, and I'm going to using it sns.count plot, just showing up. You can also add it inside your research paper, even your thesis or project, so that it's look like the convenient. Okay, so I'm going to using here the gender, and inside that I'm going to pass in here my data div. Now you can see here most of the people are the male and there is lowest number of people are the female. Okay, that's been male are generally affected by the liver disease mostly, and female is not so big. You can see here just having the 120 or 130. Okay, but inside this whole data set it's having the 441 features are nothing but the male. Okay, this is how you can do the distribution of the categorical features. So now what I can do, I am simply going to uh, checking for the data set for the mail. I mean how many values are available inside that. Just you're going to extract the data from here so that you can see it. So let's say df, and inside that I'm going to using here my gender. So gender, and let's say if the gender is equal to male, then I am simply going to show the head, just making it into data frame. Okay, and now inside that I'm just going to taking this data set column. I mean how many values are available here. So for that I'm going to using here my data set and also my gender. Okay, let's say gender just showing up as a data frame. So let's say check this out. Just for simple things. You can see it's now converted into data set and the genders. You can also save it inside your directory as a data set, having the data set and the gender male. Okay, you can also add it inside your research paper, even your final year project also. So let's try to do one factor plot because I see there the relation between the gender and the data set, because in this data set there are the most of the peoples are the male having the liver disease. Most of the people are having the liver diseases. Okay, I mean gender is most frequent features in this data set. So what I can do, I can also check this out inside in the factor plot so that we can see that if there are any relations between the uh, gender with the data set target column. So for that I can also using here the sns dot factor plot. So factor plot, I can simply using the factor plot, and inside the x-axis I can give here the age and also in the y-axis, I can also giving here the gender, because gender and age is also one the two important features. Okay, क्योंकि जब एज तो होता है तब तो लीडर डिजीज ऑब्वियसली होता है ना, तो इसलिए एज और जेंडर भी बहुत इंपॉर्टेंट है. Inside this U I am just going to taking the data set because this is my target column, so that's why inside this I'm going to giving him a hue, and data set is nothing but my df. Okay, simple. So it will give you one factor plot in your data set. So 0 means it's nothing but my it don't having the liver disease, and 1 means having the liver disease. So now you can see in the male, and the female, it having the most of the columns, and it having some factor. Yes, it's really a factor. It's two are nothing but a factor of the liver diseases. That's the age and the gender is nothing but one factor of the liver diseases. Some relation have happened, इसलिए liver disease हो रहा है. एज बढ़ रही है तो जेंडर मेल है तो डिजीज शायद होगा ओके बट इट्स नॉट सो कन्वीनियंट क्योंकि यहाँ पर और भी फीचर है वो भी इंपॉर्टेंट है लेकिन मेल एंड एज इंपॉर्टेंट फैक्टर है यहाँ पर इसलिए वी ट्राई टू एनालाइज द फैक्टर प्लॉट okay now what I can do uh, we can also try to checking that number of male and the female but we already do it out here we can check here 55441 and nothing but male so what I can do we can simply creating here one thing let's say df of gender so that we can see it because we're checking for the male let's checking for the female also in a just numerical type let's say below counts simple okay you can see here male have the 441 and the female having the 142 okay simple value counts now you can also do the plotting of the and you already do the plotting here right this is how it actually look like the flaunt now let's try to also convert our gender column into the 0 and 1 so we can see a male having the greater number of features so we can convert this male to the 0 and female to the 1 because gender is also a categorical value and it's also handle it out categorical value handle simple okay so let's say try to def convert gender so it will take one x let's say x so if the x is nothing but the male so if the male so let's try to return here the 0 otherwise let's try to make it return here the 1 okay simple I mean we're going to making this male to the 0 and female to the 1 okay so for that I'm going to also using here the df of the gender so let's say gender and I am trying to using here the df of gender okay and try to using here the function in the map so let's say using the map and I'm going to passing here the convert gender so convert gender okay okay having some problem else return okay you need to also make it inside that okay किधर गया भाई इधर पे तो ध्यान पड़ेगा शायद पाइथन भूल गया मैंने okay now let's convert it into the numerical column so if I try to check this out df.head now you can see it having the gender column is converted into the numerical column now all the columns is nothing but in a categorical column okay in a categorical column now let's checking for the outlier and also the correlation because correlation is really actually important how you're trying to select the features and try to remove the outlier from your data set you can simply checking for that so let's say I have in the positive correlations with my data positive correlation with my data let's say df.code uh, let's say I have in the positive correlation with data that's mean one feature is increases that means another feature is also increases that means they are the positively correlated if I select let's say I have a gender and let's say I have a total bilirubin and also the direct bilirubin so if there is a highly correlated if the two features are highly correlated I mean the positive correlation that's mean higher the total number of bilirubin increases direct bilirubin is also increases that's mean from there you can select any of them that's called the feature selection part if there is a negatively correlated if see if the value total bilirubin to the let's say alamine this one it's is a negatively correlated that's mean high in this total bilirubin is increases this alkyne by alamine is alamine not alkyne actually alamine is decreases I mean high in the one value is increases another value is increases high in the one value is increases another value is a decrease that's called the negative correlations okay this is how the correlation actually works so if this value is closer to the 0 that's mean there have a weak relationship between your data set okay this is how the correlation actually works that's mean how it is having the positive correlation that's mean high uh, means one feature increases other also increases okay if they are the negative correlations and negative correlations like the these correlations. That's mean one features feature increases, other others decreases. Okay, decreases. Okay, that's the negative difference between the positive correlations and the negative correlations. If there is a zero, okay, if it is closer to zero, let's say it is closer to zero, that's mean it having the weak relationship. Okay, it's not this kind of relationship जो आप करते हैं, और रिलेशनशिप नहीं है, डेटा का रिलेशनशिप है. ओके, so this is positive correlations, negative correlations closer to zero, it's mean weak correlationship. Okay, so now what I can do, you can also using here the heat map in order to show the correlation matrix. So for that I'm going to using here the plt.figure first, plt.figure. Then I'm going to give here my fixed size, and I'm going to give here 10,10. सो मुझे थोड़ा हिस्की आ गया था, तो वो शायद मैं मेरा वीडियो में होगा, शायद मैं काट कर दूंगा जब एडिटिंग के पार्ट जाएगा तब. ओके, ऐसे डॉट हीट मैप, क्योंकि सर्दी आ गया शायद. ओके, हीट मैप. सो आई एम गोइंग टू गिव हियर द डीएफ डॉट कोरिलेशंस. सो लेट्स अ कोरिलेशन आ गया यहाँ पर. नाउ यू कैन सी हियर दिस इज माय कोरिलेशन मैट्रिक्स. ओके, दिस इज माय कोरिलेशन मैट्रिक्स. नाउ यू कैन सी हियर इट हैविंग सम color, but color is not so looks good. मुझे अच्छा नहीं लगा. सो इसलिए मैंने क्या किया, मैटप्लॉटलिब से मैंने लिस्टेड जो कलर मैप है ना वो इंपोर्ट किया है. यहाँ पर देखो, लिस्टेड कलर मैप. सो नाउ आई एम गोइंग टू यूजिंग दिस लिस्टेड कलर मैप inside my correlation. So in this correlation I just need in this diagonal below. Okay, this is this diagonal below, so I don't need this one. So what I can do, I simply going to make one try you creating a marks of that, and try to removing these tags, and also try to change the color so that I can take this input as a negative correlated or the positive correlated like that. So for that what I can do, I am simply going to creating a marks. Okay, let's try to creating a marks. So marks तो थोड़ा लेते हैं चल यहाँ पर. Okay, so I can using here the zeros marks, or you can also using the ones marks. So let's say zeros like, and I'm going to passing here my df dot correlations. Pass कर दिया. Then I'm going to creating here the marks. So marks into these marks, I'm going to giving here that bit of try u, so that I can give here the diagonal below. So try u, and try u includes so indices from marks दे दो यहाँ पर. Okay, if it is true, then I'm going to remove this diagonal below of my sns.heatmap. So plt.figure, and I'm going to using here my fixed size. Fixed size ज़्यादा दे देना. Okay, 10,10. Then I'm going to using the width sns dot let's axis style. थोड़ा axis style देते हैं यहाँ पर, थोड़ा अच्छा तो हो जाए ना. So white दे दे, अच्छा होगा. Okay, now I'm going to using here x equal to sns dot heatmap. Then I'm going to using here my def dot correlations. So correlations, if I see the correlations, you can see it's nothing but in a 0.08. So we can also do the 100 into the 100, so that it's look like the 90% correlated, or the 80% correlated, or 70% correlated like that. Now I'm going to passing here marks. मार्क्स दे दो, नहीं तो कोरोना हो जाएगा, कबेट हो जाएगा. मीन एफ एम टी लेट्स कितना पॉइंट चाहिए तुमको, कितना पॉइंट, 0.2 एफ भी दे सकते हो. अच्छा, पॉइंट नहीं चाहिए, पॉइंट नहीं दो, पॉइंट नहीं चाहिए मुझे. ओके, देन आई एम गोइंग यूजिंग हियर एनोट. एनोटेशन चाहिए, हाँ चाहिए. एनोटेशन के बिना तो हम यहाँ से वैल्यू नहीं देख सकते. सो लेट्स से एल डब्ल्यू इक्वल टू 1. इसके बाद सी मैप दे दो, आई मीन कलर मैप दे दो भाई, सी मैप. तो क्या क्या कलर देगे तुम यहाँ पर. So let's say using the listed color map, and I'm going to giving here some colors. तो क्या क्या कलर देगे तुम यहाँ पर. तो बेसिक कलर तुम दे सकते हो यहाँ पर. So let's say रेड ग्रीन ब्लू दे दो, ग्रीन दे दिया. इसका बाद लेट्स से येलो दे दो. इसका बाद है ब्लू दे दो और रेड दे दो. अच्छा, रेड दे दो, ब्लू दे दो, ब्लू ब्लू. ओके, ब्लू आ गया. ओके, दैट्स फाइन नाउ. So it's inside the things. Now if I try to plot it out, now you can see it's look like good better. यहाँ marks हो गया, white marks हो गया, जो white marks है. Now you can see here it having if I see here, it's just like the gradient type. But when you see this out, you can see this is a green, 20 minus 20 to 0, and this is the 0 to 20, and this is the highly correlated. That means 87, 79, 87, 878, 69 are highly correlated below. Are highly correlated below. Okay, so that's what showing up the below. And red is nothing but red. You can see red. Red is nothing but is medium. Okay, and this is also medium, and this is the negative correlate. It's closer to 0. Okay, minus 4 is nothing but a, it's weak. Okay, it's weak. So you can see now correlation matrix, and now from that you can check that which one is highly correlated and which one is not. So now let's checking for also the duplicate value, is there any duplicate value or not. So for that, I am going to drop the duplicate from my data set. Okay, so that's a df dot drop duplicate. I'm just simply going to remove the drop duplicates value from here because it's not necessary inside my data set. Let's say df, and if I try to checking the shape now, so df dot shape, now okay, okay, tuple update shape, shape चाहिए मुझे. Okay, now you can see each having the 570 13 duplicate value था वहाँ पर वो remove हो चुका है यहाँ पर. There should be ma'am duplicate value inside data set. What I can do is simply going to remove it out. We can simply remove it out. नहीं चाहिए, लेकिन if there are more amount of duplicate value, that's you need to handle it then. You need to handle it down. Now what I can do is simply going to checking for the uh, outlier. We can see inside that if I checking this one, where is it? If I try to check with the describe that you do earlier, describe. So you can see here, there is a highly correlated, right? That is maybe the outlier inside my data set. That's called the aspirate amino transferase, maybe shayad. Okay. So we can copy this out. If I checking also here inside my correlation matrix, okay, you can see here there's some negative correlator also. Okay, okay. So what I can do is just going to remove the outlier. So let's check in removing the outlier. So for that I'm going to using here the box plot, SNS dot box plot, in order to checking the outlier. So let's say df dot this column. Well, oh my god, oh my god, oh my god, there are so many outlier. There are so many outlier in our data set. If I try to checking for another one, let's try to checking for another one. कौन सा देखिए यहाँ पर. अच्छा, let's try to taking the columns value. Okay, here is it, df dot columns. Okay, so let's checking for also the alamine, this one जो मैं बार बार alkyne बोल रही हूँ यहाँ पर. Okay, so it's also having the outlier, but that's not so much. That's not so much. This having the value of the 2000, but there you can see here it having the value rather than 2000. Okay, rather than 2000. Okay, if I try to check in another column, let's call the total bilirubin. Let's try to check this out and try to make it out. Thus, okay, total bilirubin किधर है भाई? Let's try to check in the total bilirubin and try to pass it here, and here is it. And now see, they're also having the outlier, but you see which one is not greater. Okay, so what I can do is you can also remove those outlier from your data set. But when you're trying to remove this outlier from the data set, your data set is quite smaller because it having just 517 column. When you try to removing all of the outlier from your data set, you don't have any data. So if you don't have any data, how can you actually predict it, right? So that's why you need to select the best one, which can having the more outlier, which can having the more amount of outlier. So you check that after the 3000, it having all of the things are outlier. All of the things are considered as the outlier inside this aspirate amino split. Okay. So now what I can do is simply going to remove it. We can simply going to remove it. But better, we can also do the checking for the value counts, so that we can check this from where to where I can select and try to remove the outlier. You can also using the another technique that I discussed earlier in my breast cancer detections and also the diabetes prediction value. How can you calculate the IQR value? I mean inter quantile percentage difference. You can also using this technique in order to remove the outlier from your data set. But here you can see this is a quite small number of data set. I mean quite a small number of value inside the row. So that's why you need to select some feature which one is not convenient, so that we can remove this. We can remove the outlier, just low amount of outlier. Otherwise, our data set is quite low. थोड़ा छोटा हो जाएगा, नहीं तो मैं प्रेडिक्ट नहीं कर पाऊंगा लेबर डिजीज को. लेट्स ट्राई टू यूज द शॉर्ट वैल्यू. शायद आपको समझ में आया हो. ओके, नाउ आई एम गोइंग टू गिविंग हियर असेंडिंग डिसेंडिंग जो तुम्हें आता है शायद. असेंडिंग डिसेंडिंग तुम तो शायद डी ऐसे में पढ़ा होगा. असेंडिंग करो, डिसेंडिंग करो, शार्टिंग करो. ओके, ये क्या है भाई? df डॉट एस्पेरेटिव इनस्ट्रियर. द शॉर्ट वैल्यू असेंडिंग इक्वल टू ट्रू. असेंडिंग ट्रू किया फॉल्स में दे दो, डिसेंडिंग में हो जाएगा. ओके, क्योंकि हमें तो बड़ा वैल्यू चाहिए. ओके, बड़ा वैल्यू चाहिए. आई मीन व्हिच वन इज आउटलायर, तो इसलिए मैंने असेंडिंग कर दिया फॉल्स. ओके, डिसेंडिंग ऑर्डर में हो गया अप. नाउ यू कैन सी हियर आफ्टर द 2946 यू कैन सी दैट अ ह्यूज डिफरेंस. देखो भाई कितना डिफरेंस है, 1000 की डिफरेंस है. यू कैन सी जस्ट हैविंग द 100 गैप, 100 गैप. यहाँ पर भी गैप है, यहाँ पर भी गैप है, लेकिन यहाँ पर थोड़ा ज्यादा है. देखो 1000, शायद 1000 का द गैप 2000 का गैप है. तो व्हाट आई कैन डू इज सिंपली गोइंग टू रिमूव इट. यू कैन सिंपली गोइंग टू रिमूव इट फ्रॉम आवर डेटा सेट. देखो भाई स्लोली करना पड़ेगा आपको, नहीं तो आपका डेटा सब गायब हो जाएगा यहाँ पर. राइट, आपका डेटा सब गायब हो जाएगा. दैट्स व्हाई सिलेक्ट दिस डेटा सेट. ओके, df डॉट लेट्स के सेकेंड इसको दे दो यहाँ पर. लेट्स इज ग्रेटर इज इक्वल टू 3000 के बाद सबको सिलेक्ट कर दे यहाँ से, मुझे नहीं चाहिए. ओके, df इक्वल टू दिस वन. ओके, इफ आई ट्राई टू चेक इट नाउ df डॉट शेप. देखो कितना वैल्यू कम हो गया. ओके, एक वैल्यू था वो कम हो गया, थोड़ा जस्ट वन वैल्यू था वो कम हो गया यहाँ से. सो नाउ लेट्स ट्राई टू चेकिंग द वैल्यू काउंट अगेन. यहाँ से कॉपी कर दो, मैंने पेस्ट कर दिया. देखो तो यहाँ पर तो सेम गैप है ना, यहाँ पर भी गैप है. तो मैं क्या करूँ, इसको भी डिलीट कर दो यहाँ से. तो कॉपी किया. सो वी कैन ऑल्सो डिलीट इट फ्रॉम द 2500. यहाँ से भी मैं डिलीट कर सकता हूँ, क्योंकि शायद यहाँ पे होगा, यहाँ पे हो सकता है, क्योंकि यहाँ पर तो बिल नहीं देखता मुझे. ओके, ये पर तो मोर you can also use it from the 2000. You can also use it from the 2000, but लेकिन the problem is the data set is quite small. देखो यहाँ पर एक गया है. If I try to make it 2000, if I try to make it 2000, तो शायद वहाँ पर और भी वैल्यू हो सकता है, यहाँ पर और भी वैल्यू हो सकता है जो यहाँ से रिमूव हो जाएगा. तो if the data is removed, तो how can you predict the liberties? इसलिए आपको ध्यान सोच समझ के आपको जो वैल्यू है इसको क्या करना पड़ेगा, आपको डिसाइड करना पड़ेगा लोअर डेटा सेट में. दैट्स वन प्रॉब्लम इन द लोअर डेटा सेट. डायबिटीज में बहुत सारे वैल्यू था, ब्रेस्ट कैंसर में बहुत सारे वैल्यू था, लेकिन यहाँ पर कम वैल्यू है. आई मीन लो अमाउंट ऑफ वैल्यू. मेरा हिंदी इतना अच्छा नहीं भाई. लेट्स से df डॉट शेप. देखो आप. ओके, अब भी चला गया, हो गया, मुझे और नहीं चाहिए. ओके, 5608 इज एनफ फॉर नाउ. तो नाउ लेट्स चेकिंग फॉर द नाल वैल्यू है और नहीं. इस नाल देखो ये तो क्लिनिकल पार्ट है, यहाँ पर कर रहे हैं हम. ओके ओके, नाल वैल्यू तो नहीं है, लेकिन 4 वैल्यू है यहाँ पर. तो यू कैन ऑल्सो ट्राई टू इम्प्यूट इट, अदरवाइज यू कैन ड्रॉप इट. 4 तो वैल्यू है ना, इतना ज़्यादा नहीं है. इट्स नॉट सो मच. सो व्हाट आई कैन डू सिंपली गोइंग टू ड्रॉप इट आउट. ड्रॉप कर दिस, ड्रॉप ना. एंड हाउ दे दो, एनी दे दो यहाँ पर. Let's try to give it any. Okay, हो गया डिलीट. लेट्स ट्राई टू चेकिंग द हेड. हेड अच्छा है, शेप चेक कर ले. शेप. नाउ इट्स ऑल क्लीन डेटा. इट हैविंग 564 row and 11 columns. Simple. Okay, so our data set is now clean. Now what I can do, we try to building our machine learning model now. Building our machine learning model. इस सीरीज आपको पसंद हुआ तो सब्सक्राइब कर देना भाई. ओके ओके, नाउ लेट्स टॉकिंग फॉर डेटा प्रिपरेशंस. थोड़ा मेहनत तो लगता है ना, प्रिपरेशन. ओके, डेटा प्रिपरेशन करते हैं आप, इसलिए फॉर टारगेट वेरिएबल एंड ऑल्सो द features column, or also called the dependent and the independent features. So इसलिए क्या करते हैं आपको df equal to df dot data set के यहाँ से ले लेते हैं. डेटा सेट x में क्या देते हैं, x को थोड़ा बड़ा से ले लो क्योंकि बहुत सारा है ना यहाँ. तो वी कैन सिंपली ड्रॉप द डेटा सेट फ्रॉम हियर, क्योंकि एक्सेप्ट द डेटा सेट कॉलम, आई एम ट्राइंग टू टेकिंग ऑल द कॉलम इनसाइड माय फीचर्स कॉलम. तो एक्सिस देना पड़ेगा, कहाँ से भाई, रो से, कॉलम से दे दो. Okay, so now our data set is splitted. Now what I can do is simply going to import all of the necessary element now, which one is required in order to building one machine learning model, in order to building one machine learning model. So for that, I am going to importing the train test split and also the algorithm, which one is really important in order to building the machine learning model. So let's try to import it. Let's say from sklearn dot model selection, selection, import the train test split. हो गया. Then I'm going to import in here some matrices from here, sklearn dot matrix. So you can also using here the tab. It will give you the auto sessions. Auto session दे दे, नहीं तो मारूंगा तुमको. Okay, matrix नहीं आ रही है, शायद गुस्सा हो गया. गुस्सा तो हो गया क्योंकि यहाँ पर भूल हो गई अच्छे से. Let's import the accuracy curve और accuracy score. इसका बाद है confusion matrix जो मुझे confuse कर देते हैं. इसका बाद है classification report जो मुझे चाहिए, नहीं तो मारेंगे मुझे. इसका बाद है search score sklearn dot model selections. I'm going to importing here the grid search से भी मुझे चाहिए क्योंकि यहाँ पर hyper parameter tuning भी मुझे करना है. You can also do the cross validation if it is needed. So let's try to also import it out. Model selection का अंदर है, so import कर लेते हैं इसको. Import here the cross validations. Let's say val score. Let's try to also import here some machine learning algorithm. Let's try to import it here. So let's say from sklearn थोड़ा और भी सेल लेते हैं यहाँ पर. sklearn dot linear model. I'm going to importing here the logistic regressions. Logistic regression आ गया. इसका बाद है from sklearn dot ensemble, and I'm going to importing here the random forest classifier. Random forest classifier. Okay. Then from xgb post, I'm going to importing here the xgb classifier. Okay, classifier. Okay, it's xb xgb classifier. Then we have in the decision tree. So let's say from sklearn dot tree, I'm going to importing here the decision tree. Okay, decision tree classifier. Okay, then I'm going to import the sbc. Let's say from sklearn dot sbm, I'm going to importing here the sbc. बहुत हो गया भाई और नहीं चाहिए मुझे. Okay, see, just sum up it here. First we import here the train test split because you need to divide our data set into training part and the testing part. Then you having the accuracy score, then you having the confusion matrix, then you having the classification report, then you import here the grid search cb, which actually help you to choosing the best hyperparameter from your machine learning algorithm. Then you have the cross validation score, then you have the linear model, and from the linear model you put here the logistic regression. Then you have the random forest classifier, the xzb classifier, then you have the decision tree classifier, which one is really convenient. Then you have the sbc. So now let's try to divide our data set in the train test split. Train test split. Now I'm going to passing here my x and the y and giving here the test size. So test size, and I'm going to making here test size 0.2, 20%, 80% लेते हैं यहाँ पर. Let's say random state, so it's not changing the state again and again. Okay, let's try to making the statify आप देते हैं यहाँ पर, तुम दे सकते हो, नहीं तो दे भी नहीं सकते हो. So df data set दे सकते हो यहाँ पर. Others you can pass it the y. ओके, डेटा सेट डिवाइड हो चुका है, सो बेटर वी कैन डिवाइड। देखो यहाँ पर 4 पार्ट हैं, देखो 1, 2, 3, then you have the 4, okay, 4 like that, 4, yeah, you can see 4, okay, this one, okay. So that's why what I can do is simply going to divide our data set into 4 things. तो क्या क्या होगा, फर्स्ट होगा हमारा x ट्रेन, इसका बाद होगा x टेस्ट, इसके बाद होगा y ट्रेन, इसके बाद होगा y टेस्ट. So that's why you have in the 4 variable. देखा क्यों हो गया. Now we need to also standardize our data, क्योंकि यहाँ पर तो कुछ वैल्यू है उधर 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 उधर, तो it's better we can make it in a single range, -1 to 1. We can do the data standardization. Otherwise, you can also using here the standard scalar function from your scalar, but I am trying to take it in the raw, क्योंकि हम तो raw करेंगे, यहाँ पर खुद से बनाएंगे, हम खुद से आज बनाएंगे स्टैंडर्डाइजेशन, जो स्टैंडर्ड स्केलर बोलते हैं, डेटा स्टैंडर्डाइजेशंस. ओके, इसको हम बनाएंगे, खुद से बनाएंगे. कैसे बनते हो? ओके, देखो तुम इंपुट भी कर सकते हो यहाँ पर फ्रॉम स्केलर डॉट स्केलर, यू कैन आल्सो इंपुट द स्टैंडर्ड स्केलर. तो इससे ज़्यादा तुम क्या कर सकते हो, तुम खुद से भी इसको बिल्ड अप कर सकते हो, खुद से भी आपको बिल्ड अप कर सकते हो. इसलिए आपको लगेगा ट्रेन मीन लगेगा, ट्रेन मीन. सो मीन वैल्यू, लेट्स से एक्स ट्रेन से मीन वैल्यू ले लो. तुम क्या कर सकते हो, इसका बात है टेस्ट, नो सॉरी ट्रेन, देन इसका बात है आपको लगेगा वो स्टैंडर्ड डेरिवेशंस, स्टैंडर्ड डेरिवेशन परिमित व्यवधान बोलो नाকি. ओके, लेट्स एक्स ट्रेन डॉट एसटीडी. ओके, स्टैंडर्ड डेरिवेशंस, इसका बात है मीन. ओके ओके, অলসো ওয়ান থিং, টুডে ইজ অলসো 21শে ফেব্রুয়ারি, আজকে হচ্ছে আন্তর্জাতিক মাতৃভাষা দিবস. আমি চাইছিলাম ভিডিওটা হচ্ছে বাংলাতে করব, বাট ইটস বেটার আই ক্যান ডু ইট ইন ইংলিশ বিকজ there are so many audience from the outer country like India or the USA, any of them. So সবাইকে আন্তর্জাতিক মাতৃভাষা দিবসের শুভেচ্ছা, হ্যাপি ইন্টারন্যাশনাল মাদার ল্যাঙ্গুয়েজ ডে, and I am also proud to be a Bengali. আমি গর্বিত আমি বাঙালি হিসেবে. So thank you. So now what I can do, I am simply going to making the x train equal to x train, then I'm going to making the train min, यहाँ से दे दो, then you can divide it simple standard deviation. So train standard deviation, simple. Now our data set is converted into the in a simple format. Okay, in a simple format. Now you can also check it out. Let's say x train, you can also using the describe. Okay, now you can see here we have in the all of the value, we have in the all of the value is nothing but now -1 to 1. Slides between -1 to 1. You need to do the same thing. You need to do the same thing for the test. Okay, that's why I'm going to copy this out, and I'm going to make it here, and I'm going to make it as test, and also try to make it as x test. देखो कैसे करते हो तुम, सेम यहाँ पर भी काम कर सकते हो. टेस्ट डिस्क्राइब, तुम डिस्क्राइब भी कर सकते हो, डिस्क्राइब. ओके, सो देखो यहाँ पर सब कुछ सही है यहाँ पर. ओके, all the things are good. Now the question is, why should I actually speak in English, Hindi? Because most of the audience are coming from the India. Even though I also like to like the Indian peoples, so that's why I decided to because most of the audience are from the India, so that's why I speak in Hindi. Okay, but Bangla is my mother tongue. Okay, I'm Bengali. Okay, now what I can do, I'm simply going to fitting with the models. So for that, first I'm going to importing here the logistic regressions. So let's say logistic regression. Okay, now what I can do, I'm simply going to using the LR, that's LR equal to logistic regressions, and I'm going to fit it. So let's say LR dot fit, and I'm going to passing here my x train and also x test. Okay, not x train, okay, y train, simple. Okay, so now my logistic regression is created. Now what I can do, I simply going to using this to predict our data. Let's predict, and I'm going to passing here my x test. Okay, and try to make it y predict. It's y prediction. Okay, that's fine. Now we can checking for the accuracy score. and also the confusion metrics, and also for the classification report. So for that, I'm going to import. I will import here the accuracy score, so I can using here the accuracy score, and I'm going to passing here my y train, and also I'm going to passing here my y predict. Then after that, I'm going to just store it inside one variable. Let's call the LR uh, accuracy, accuracy like that. And now what I can do, I can also do the same thing for the testing. So what I can do, I simply going to copy this out. Uh, okay, let's try to print it out from here. Let's try to print it out, because this is testing. Training, it's not needed. We just needed the testing one, because it's actually important. So a score is nothing but the y train and the y predict, y train and the y predict. So it's will be the y test, and I'm also using here the lr dot predict, and I'm using here the my test data. So test data, okay, x test. Otherwise, you can also using this same thing, so that you can copy this out again and again. You can just simply copy this out and try to make it lr dot predict, and I'm going to make it train. Okay, train. Okay, so if I try to now checking for the accuracy, it having the 71% accuracy on the training data. If I try to checking for also the testing data, so let's try to printing on the testing data. So you can see it having the 76% testing data. Oh, my bookmark is opening. Okay, you can see here the testing data, 76% of the testing data set. Not so bad, not so bad. Okay, so now what I can do, we can also checking for the confusion matrix. So I am simply going to also print it here. So let's say confusion matrix. So confusion matrix. So confusion matrix, and I'm going to passing here my y test, and also the y predict, this one, y predict, and this is my confusion matrix. So simply I'm going to print it here, so that I copy it for the other of these cases. Okay, then I'm going to printing here. Otherwise, I can also creating one function which will give me the accuracy score and also the confusion matrix also. So let's try to make it the classification report, and I'm going to passing here my y test, and also the these things lr.predict, and this one, simple. I can also otherwise creating one function which will give me all of the values. Okay, so you have the confusion matrix, and you have the precision, the recall, the f1 score, and the support. Okay, so this is how the logistic regression actually work. Now let's apply another machine learning algorithm. It's called the knn. So knn also same like that. So what I can do is simply going to maybe we import it here. शायद यहाँ पर import कर लिया और नहीं. Let's see, we don't import it here. So what I need to do, I need to also import it here. So for that, I'm going to import it. Let's say from sklearn dot neighbors, I'm going to import here the k neighbors classifier. Okay, neighbors classifier. Then I'm going to simply creating here an instance of knn, and let's say k neighbors, and I'm simply going to use the knn dot fit to the data. So that's my x train and the y train data. Okay, it's fitted. Now what I can do is simply going to do the predictions. So for that, I'm going to using here knn dot predict, and I'm going to passing here my y train data. Okay, y train or y test. I need to pick here the x test. Sorry. Okay, now you're having the value. So I can simply copy this out from here. Just copy this out and I paste it here and try to making this knn. So it's the knn accuracy. It's going to be the knn. Let's make it knn, and I'm going to copy this knn, and I'm simply going to make it knn accuracy, this knn, and the knn. Okay, now it having the classifier. Okay, it having a knn accuracy. Okay, knn accuracy. That's showing me the knn. Okay, in knn it having the 66% accuracy. So here you can see it having the 76% accuracy on the logistic regressions. But the testing accuracy is training accuracy 71% and testing is 66. And this is the confusion matrix and the precision, recall, the f1 score, and support. So in this series also I decided that I am trying to discussing about the some basic theoretical technique like outlier detection. I mean, how many types of technique are available in order to detect the outlier, and also discuss about the correlation matrix. Also discuss about the confusion matrix. Then what is the precision? What is the recall? All of the basics theory I am trying to explore it here in this series. So maybe in the later on, I am trying to creating one extra videos for that. What is precision? What is recall? What is happiness score? How can I calculate them for the mathematical all the time? I'm trying to discussing about this here. Okay. So now what I can do, I am simply going to now using here the SBM. That's called the support vector machines, or you can say SBC, also the support vector classifier. So this support vector classifier having the hyperparameter. So we can now start the hyperparameter tuning because the SBC and the decision tree classifier having the hyperparameter. Well, so now we're going to say the SBM, also called the support vector machine. Even they can also say that SBC, also called the support vector classifier. So let's try to import it here. I think I already imported the SBC. Now what I'm going to do, I'm simply going to create one instance of that called the SBC equal to SBC. Okay, in a capital letter. Now what I'm going to do, I'm simply going to create the parameters and also try to making the probability should be the true. Let's make it true. T capital है, so true. After that, I'm going to giving here the parameters because the SBM, also called the SBC, having some hyperparameter. Now, using this parameter, I can do the hyperparameter tuning. It will choose the best parameter inside my parameters. So let's say parameter and meters. Okay, meters. Okay. Now I'm going to giving here the value of the parameter. So it having the two parameters. First parameter is called the gamma, and another one is called the C. Okay, capital C. Fine. Now inside that, what I'm gonna do, I'm simply going to giving here the value. Let's say 0.001. Then we can give here 0.001, 0.01. Then we having the 0.01. Then we can give here 0.1. Okay, that's it. You can also giving here the one. Now let's also give here the C value. Let us start from 0.01. You can give here some random value also. Let's say 0.05, 0.5, 0.1. Then we having the 1. Then let's making here 10. Let's also give here 15. Let's give here 20. Let's give here 30. You can give any one of them. Just choosing the best one. Okay, so it's my parameter value. Now in this parameter, I have to search the best parameter. I have to search the best parameter, which one is more convenient, right? So for that, I'm going to using here my grid search CB. Let's call it grid search CB. Hare bhai, kidhar gaya? Grid search CB, and inside that, I'm going to passing here my SBC, my model, and also my parameters. That's it. And now let's assign to the variable. It's called a grid search. Let's call grid search. That's it. Now using this grid search, I'm going to do the fitting. Fit our X string and my Y string. Simple. Now it's fit our data. Now inside this grid search, I need to select the best parameter and the best score. Now you can see estimator is SBC and it having the probability of the true, and this is my grid search CB. Okay, this is my estimator, the C value and the gamma value. Now what I can do, I need searching for the best parameter, which one is I can pass inside my SBC. So for that, I'm going to using here the grid search dot best estimator. You can select the best parameters. You can give it here. Let's give here the best parameters. So we have the parameters called C equal to 0.01 and gamma is 0.001. It selected this one. Let's try to also printing here the score. It's also called the accuracy score. You can also say like that dot best score. So best score चाहिए मुझे score by आजा 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 आ गया. So we got here 71% accuracy. Okay. Now what I can do, I am simply going to put it inside my SBC. So for that, I simply going to copy this thing. And paste it here, and I'm going to remove this parameter, and also I'm going to remove this grid search CB. And now what I can do, I'm simply going to make it SBC like that. Now I'm going to passing here all of the value that I actually get here, all the C value and the gamma value. Let's just see equal to 0.01, and gamma, also called gamma, gamma equal to 0.0001. Simple. Okay, now we have the SBC, I mean our model. Now what I can do, I'm simply going to copy this one because it's necessary. It's necessary. So we can also creating one function for that which can give me the accuracy and also the score. So for that I need to using here this KNN to SBC. Okay, this SBC and SBC, this let's make it SBC also, and let make it SBC. It's also SBC, also SBC. Simple. Now it gave me the predictions with the training accuracy 71% and testing accuracy 71%. That's really fine. You can also creating here or define here a function which is taking the y train and the y test and also the y predictions. You can also give it like that way. Okay. So now after that, what I can do, this is nothing but training accuracy and this is my testing accuracy, right? So what I can do now, we can apply another machine learning algorithm. So let's select here another machine learning algorithm called the decision tree classifier, which are also having the hyperparameter, which also having the hyperparameter. You can also tune in this hyperparameter. So for that, what I can do, I am simply going to create here the instance of the decision tree. So for that, you can also do like that. Otherwise, you can also just creating here the decision tree classifier and try to fit it out. So now I am going to first going to import here the decision tree called DTC equal to decision tree classifier. So decision tree classifier, just creating one instance of that decision tree classifier, and I am going to using the fit. Let's call DTC dot fit, and I am simply going to pass here the X train and the Y train. Simple. Okay, now you have the decision tree classifier. Now same thing or same way you can also classify the score of that. Simply going to copy this one and I'm going to change this to the DTC, just DTC, and let's try to make it DTC and make it DTC. Okay, same thing here, same thing here. You can also, it's better you can creating one pipeline, but when I go deeper you are also going to creating one pipeline. So it seems like it will overfit our data, our training data, and we get here 63% accuracy, which is really very less. So now what I can do is simply going to do the hyper parameter tuning in our decision tree classifier. For that I'm going to, let's say, taking the grid parameters parameters. So let's say it having some parameter having the criterion. So let's say array criterion, and it having the two criterion. One is called the Gini and another one is called the entropy. Okay, there's a nothing but my decision tree the entropy. So entropy. Okay, that's it. And then we having the max number of depth. I mean कितना depth होगा हमारा decision tree का length. So max depth तुम यहाँ पर select कर सकते हो. Let's say 3, 5, 7, 10, 12, 15. You can select any of them. Okay. Now let's select here one splitter. So let's say splitter. Now you can also giving here the best splitter, or otherwise you can also select the random splitter. So best and random. आपको कौन सा select करना है? Okay, fine. Then we have the min sample lib. So we have the min sample slip. Okay, then we having the min sample split. So you can also giving here range. Otherwise, you can give here 1, 2, 3, 4, 5. Okay, let's give here 3, 5, and 7 like that. Now let's also giving here uh, the mean sample split also. Copy this out. Let's say mean sample split. So let's make it split like this way. And now also give you the max number of features. So let's say give here max features. Okay, that's it. So you can select here the max feature, like it having the auto then you having the skewered. Okay, then we having the log base too. That's the parameter. You can use this one. Now let's try to do it using the grid search CB. Otherwise, you can also using the random search CB also. So let's give here DTC, and inside this grid parameter, I'm going to passing here my grid meters, okay, meter or meter. Then let's say cb कितना फोल्ड चाहिए मुझे 24 दे दो. हिट एंड ट्रायल एम जॉब्स नहीं चाहिए. एम जॉब्स नहीं चाहिए मुझे. बारबोस 1 दे दो. Okay, now what I can do, I'm simply going to define it, actually define it inside a variable that's called a grid search dt. Okay, that's it. I'm going to copy this out and I'm going to make it here to fit our model. So fit our model dot uh, dtc dot fit xtrain, not xtrain, and also having the white train. Simple. Now it is fitting with the 24 fold. You can also giving here any kind of fold, 5 fold, 10 fold. Okay, any kind of fold you can give here, but it's less number of data, so you can to giving here the best number of fold. You can also select cap fold. Now from that, I'm going to select here the best parameters. I mean, कौन सा best parameter है, कौन सा best estimator है, right? So for that, I can using here the grid search dt. It will take maybe 1 or 2 minutes, otherwise it will take enough time because it will fold this 24 folds, so it will having the 43,200 feet, so obviously it will take time. See, just like the SBC that you see earlier, just into changing this parameter and to select the best parameter from your hyper parameter. That's called the hyper parameter tuning. In uh, in the previous tutorial, like breast cancer classification, even though the diabetes classifications, we just see the grid search CB. But when we go to the deeper to the tutorial, we also see the various types of algorithm. I mean, various types of hyper parameter tuning algorithm. So this is my decision tree classifier estimator, and this is my grid search CB. Okay, now we need to select the best parameter. So let's the best parameter called best params. So that's my best parameter. So let's try to also checking for the score. So score kitna hai? Let's try to checking for the best score, best score, best score. Okay, that's it. As course we got here 72% accuracy. Okay, 72% accuracy. So what I can do now, we can simply going to go up here. Uh, Here is it. That's like this way. SBC. I mean the same thing here. You can see the same thing here. I'm just going to give here the parameters. Mm, Same thing here, and I'm just going to changing the parameters from my decision tree, right? Just like this way, decision tree. So for that, I'm going to passing here my parameters. क्या क्या parameter यहाँ पर है, उसको मुझे यहाँ पर pass करना पड़ेगा. So now let's try to pass it here. So क्या क्या है, criterion है entropy. Then we having the max depth है 5. Then we having the max features. We having the sqrt. Then you have the mean sample lip. We have the 7. Then we have the mean sample split. Okay, I think it is split or not. Okay, split is equal to 3. Then we have in splitter. Splitter is nothing but the best. Split is best. So split is best. Simple. Okay, now our decision tree classifier is ready. Well, now you can simply go into copy this one, the same thing, just going to changing here the prediction score. So DTC is here, simple, and going to shift enter. Now you can see here we have the 74% accuracy on the training data. But if I see before, you can see it will overfit our data. Okay, it will overfit our data. But in testing data, you can see just 63% accuracy. Now accuracy increases to the 69% and 74% accuracy on the training data. Quite good. Now let's apply some more advanced types of algorithm like a random forest. Let's call random forest. Okay, fine. So let's try to creating here one instance of the random forest. I hope so. I already imported here. Yes, I imported. And now let's give here the criterion. Let's give here the entropy. And now let's give here the maximum number of features. You can also giving here these things, all of the things, just like you can pass it inside the the random forest until decision tree classifier. You can also giving here the same thing that you pass inside your decision tree classifier, because this is the best one. Now you can also give me here one number of estimator, okay, number of estimator. So max feature. So it also giving here the max feature. You can also give here the square root, but here you have to giving here max feature in terms of one range. I have one picture, let me show you. mm, I think here is it, maybe. Yep, here is it. Okay, you can see when you select the uh, max depth, I mean depth of your features vector, you have to select any of them. If you have 20, you can make in the floating point number as a 0.1.0, or you have the max number of feature. If you select it inside the integer, you can choose 0.75. If you have 10, you can select the 0.5. Like this way, you can actually select any of them. Okay, so now let's select the max features. Max depth, let's say 15. So in the 15, I'm going to select for the 15, I'm going to select 0.75. Okay, 0.75. I can select any of them, or I can select the 0.5 also. That mean sample list, all of the things are same. Mean splitter, let's say you have the three based on my decision tree classifier. And the splitter, you can select the best if it is splitter available. And it also giving the number of estimator. Okay, estimators. Okay, estimator. Let's give here the 130. Okay, splitter is not available here. You can remove this splitter from here. Okay, and this is my random forest classifier. Now let's try to assign it inside a variable. Let's call a random classifier. So ran cls, okay, clf classifier. And now I'm simply going to shift enter and trying to fit it into my data dot fit, and I'm going to passing here my x string and the y string. Okay, so random forest is fit with my data. Now what I can do, I'm simply going to copy this out, the same thing, and I'm going to paste it here and try to making this one random classifier to the here b, control b, and try to make it random forest classifier accuracy, random forest, like this one. Now we have the accuracy 90% accuracy on the test training data, 90% accuracy, but testing data have accuracy of the 69%. 69%. Okay, so just you need to hit and trial and try to do this thing. Now let's try to add another more classified algorithm. Let's call the gradient boosting algorithm. Gradient boosting algorithm, boosting classifier also, you can say classifier, like this way. Okay, it's also having the hyperparameter. We can also do the tuning here. Okay, so for that, it also import it. I don't think that I import it here. So for let's import it now from sklearn dot ensemble. I'm going to importing here the gradient boosting classifier. Okay, let's creating one instance. Let's say gbc equal to gradient boosting classifier, and I'm trying to giving here the parameters, because this is also a hyperparameter tuning. It's having also the hyperparameters. So let's initialize here all the parameters inside my gradient boosting classifier. So let's try to take it. It's having first parameter called the loss, and the second parameter it's having also called the learning rate. It's also available inside the deep learning. And then we have the number of estimator, matters. So now let's give you the loss. So it having the two kind of loss, exponential loss and the deviance loss, deviance, and it having the exponential loss. Fine. Now let's give here some learning rate. Learning rate actually start from 0.001. Start from 0.01, the basics and the best one we actually using in the deep learning. 0.01, then you can using 0.1, then you can using 1 and 10. Okay, like this way. Now select the best one from here. Okay, now I'm going to using here the number of estimator. You can give here 100, 150. By default you give here 180 basically in all the cases. So let's give it the 200 now. So this is my estimator. Now I am going to using here the grid search CB. You can also use in the random search CB. Okay, you can also use it. Okay, that's using the grid search. That's a GBC equal to grid search CB, and I'm going to passing here my GBC and also my parameters. These my parameters, and I'm going to give here the fold. So in decision tree or maybe SBM, maybe decision tree SBM, I give here fold as a 24 fold. Let's give here 20 now. Okay, and jobs obviously it should be 0 -1, and the barbos is always 1. Well, so now I'm going to feed with my data. So let's say git search gbc dot feed my data called x train the y train. Well, so it is fitting this data totaling 720 feet. Now from this feet I'm trying to taking the okay, it's having some error maybe. So let's see what kind of error we got. Invalid parameter C for estimator gradient boosting. Valid parameter are CC alpha criterion. Okay. Uh, uh, Parameters gives us GBC number of parameters. Parameters CB equal to 20. Number of jobs equal to -1. Barbos equal to 1. But why this error? Let's see. Invalid parameter C for estimator gradient boosting classifier. Valid parameter are criterion init learning rate loss. Learning rate we give here also learning rate loss, and then we have in a number of estimators. So let's try to check it out. Now we have the loss, deviance exponential. Then we have in the learning rate, and number of estimators. All of the things are okay, but why should it give me the error? Let's try to also check this out. Is there any or not? Okay, just to wait. Okay, it actually gave me the error because I had to also give here, I actually gave here 0.001 because when you actually giving here the learning rate and the number of estimator, that should be the same. So that's why it actually gave me this kind of error. So while you're trying to choosing the parameters in a list value, make sure that your value, you can see I gave here the 4 value. So obviously in the learning rate, you're not also giving here the 4 value, but for the loss and the all of the things like loss or otherwise the criterion, that's are the nothing but the fixed size. That's nothing but the fixed size. But when actually giving here this kind of value inside this uh, classifier, I mean the running the number estimator, you need to give here the same thing in the same way. So that's why it actually gave me this kind of error, and it will give me some this kind of invalid types of parameters. Okay, so now let's select here the best parameters. So gbc. Okay, now I'm going to using the best parameters. So best parameter is nothing but my learning rate is 0.001, loss is exponential, and number of estimated is 100. So let's try to checking for the scores. So देखते हैं कि score बढ़ता है और नहीं. So let's try to using the best score. Okay, now score 71% scores. So what I can do, I am simply going to again using this gradient boosting algorithm and try to predict it. Okay, so for that, what I can do, I'm simply going to call it again this gbc and try to fit with here gbc dot fit with the x train and the y train. Okay, and the y train. That's it. Now that's it. So now what I can do, I am simply going to pass here. I mean, put here the learning rate. So call the learning rate. Learning rate just here 0.001. Then we having the loss is nothing but the exponential. Then we have the number of estimator. Let's say 100. Cool. Now our gbc is ready. So what I can do is simply going to copy this one. Okay, copy this one and try to checking for the accuracy. This is how you can actually checking all of the accuracy, all of the things, and try to do the hyper parameter to need to checking the best hyper parameter, right? So what I can do, I'm simply going to copy this one gbc again and again. थोड़ा मुझे तो थोड़ा दिक्कत भी हो रही है. Okay, let's try to use this one. Okay, to be like okay, now you can see at 71% accuracy, 71% accuracy. Okay, so we see that accuracy is not actually increases. We just got here the same things of accuracy inside that. Okay, let's try another one. Let's call the XU boost. and this is the last one, XGB boost, XG boost. Okay, now let's try to import it. I think I know how to import it here again. So let's sklearn, not sklearn, it's available inside XG boost. I'm going to import here the XGB boost, XGB boost, this one, XGB classifier. Okay, that's one. Now let's try to give here the XGB boost. Okay, XGB boost. Oh, इधर आबार हो गया this classifier, and I'm going to give here the objective. So let's give here the objective is, let's say, giving the binary logistic. Then I'm going to giving here the learning rate. आता है नहीं आ रहा है नहीं आ रहे है learning rate 0.001 that you actually see earlier, inside that 0.01, and let's give it the max depth नहीं आ रही, let's give it 100, and number of estimators, let's give here the 180, let's give here 300 now, थोड़ा देते हैं देखते हैं आता है या नहीं. Okay, now let's assign into the variable, let's call the XGB. Let's try to make it XGB dot feed X train and the Y train. Okay, it's feed our data. Now simply going to do the same thing. Just copy this out and going to paste it here. Let's make it XGB. Then we have in the XGB. Okay, XGB copy just here. थोड़ा सा इसका बात है XGB, then XGB. Okay, so we got here 69% accuracy and 93% accuracy on the training data. Okay, that's fine. Now what we can do, we can do the model comparisons. So model comparison मुझे करना है. So model comparison. Okay, now let's try to do the model comparison. So for that, what I can do, I'm simply going to create one list of the models. So let's say pd.data frame, so that we can see it inside a data frame. Let's say data frame थोड़ा YF हो जा, बड़ा हो जा. Okay, now inside this data frame, I'm trying to giving here the dictionary. So let's say we're having the model, all of the model, then we having the score C हो गया score again, थोड़ा सा mistake हो जाते हैं. Okay, let's take one list and let's give here the first model called the logistic regression. Then let's taking the KNN. Then we having the SBM, also called SBC. Then we having the decision tree classifier. Then let's taking the random forest now. इसका बात है random forest classifier. Okay, then what we have the gradient boosting, then having the XG boost. So let's say gradient boosting classifier fire. Then what do we have? Then we have the XG boost, XG boost. Okay, that's it. Now we having the list, and now we have to give here the score. So score कैसे देना है मुझे? Let's try to giving here the inside the list. So 100 से multiply करते हैं क्योंकि यहाँ पर तो 0.96 ऐसे होते हैं. So let's try to make it the round factor. Let's take the round factor value. Let's say LR accuracy. That's my logistic regression accuracy. Then we having the 100 into round of the KNN. So let's say KNN accuracy. Let's take in the fourth of round. That's 100. Then we having the SBC. So let's say take a round of SBC accuracy, let's say SAC and 4. Then we having the decision tree class of DTC. So 100 into round of DTC accuracy of 4. Then we have random forest. Okay, then you have the random forest. So let's say again 100, not 1000 actually, round of random forest. So random forest RANDCLF accuracy. Let's take it 4. Then you have in the gradient boosting, let's call 100 into round. Just taking the round below of the 4. Okay, round. Let's taking um, the for the random forest we actually already do it out. Now let's take it for GBC accuracy 4. Now let's also give here the last one. Let's call the 100 into round of the XGB accuracy SCC into 4. That's it. Now we're having the our data frame ready. Now what I can do is simply going to short it out based on the score value. So for that I'm going to using here the models dot short values, and I'm going to give here the by. So by, let's say by score, and I'm going to giving here my ascending equal to false, descending और मुझे चाहिए. Okay, now you can see here you got here the logistic regression having the 76% accuracy. Okay, 76% accuracy. That means our logistic regression is right now the king. Okay, now what I can do is simply going to import pickle in order to save it. So let's say pickle, and I'm going to save the model. Which model? A logistic regression. Let's call the LRSCC. Okay, now after that I'm going to using the pickle dot dump, and I'm going to using here my model and my open. Let's use here the liber.pickle file in the right mode. Okay, so here the one problem you can see in the testing data we're just getting here 70, just lagging the average one 70% accuracy. In the training side we got here 76% accuracy, which one is not so great. I know 70% accuracy is not so good. Maximum you need to actually taking a 85% accuracy on your data set. See, we have the limited amount of data, just limited amount of data. If you're just learning the machine learning, that's okay fine, that's okay fine. But when you're trying to or try to make it more spatial, I mean try to make getting more accuracy, you can also using here the ANN. Okay, you can also using here the ANN because this last having the less number of data. So when you have the less number of data, I know you need to using here the machine learning algorithm. But if it is try to predict it just 76%, not so bad, 76%. So it's better you can also apply the ANN. If it is giving the best accuracy, then you can select any of them. Okay. So this is how you can to save your model file, and you can also checking for the ROC curve. Okay, and also the model comparisons. You can you always see the comparisons. So you can also plot on comparison plot here. So what I can do, I'm simply going to pass here on code because this is not necessary at all. So well, so this is the code for that, just for the matrices. So you can see here the ROC curve of all of the models, and you can see a 64% ROC curve. I mean ROC value for the logistic regression. Then you have the model comparison in the graph. You can also add it inside your research paper. So you can see the performance of this logistic regression is quite great. You can 75% up. I mean 76%. You can printing just like this way. Okay, and that's the code for that. Which one is not? It's yeah, necessary when you're trying to add it inside your final defense presentations. You can actually use this one. This is how you can also printing here the model performance. So that's it for today now. Hope you enjoyed this tutorial and make sure to subscribe to the channels. And I hope you learn more of things about the machine learning, data preprocessing, the data handling, outlier detection, all the things. So that's it for today now. And thank you and bye bye.